Hey, what's up, guys? It's Zane from Chem 1412, section number 610 or 62430. Professor Fox. Today we're going to be doing experiment number 9, which is the determination of vitamin C concentration by redox titration. Before we do any experiment, it's always good to look at the reasons why we're doing the experiment and just look at the overview and the background of the experiment to give us a better understanding of the whole purpose of the experiment. So pretty much the purpose of this protocol is to determine the concentration of vitamin C in an unknown sample by performing reduction oxidation titrations. And what that is a method for determining the concentration of an unknown by exploiting a redox reaction between the analyte and the titrant, which we talked about those two in the previous labs. We will develop a standard curve using solutions of vitamin C of known concentrations. Then we're going to compare the different data from an unknown sample to the standard curve of the vitamin C, and we'll see how that goes. So vitamin C, it's always, we've always heard about vitamin C. It's also known as ascorbic acid. It's a required nutrient that is necessary for normal growth and development. It is also needed to synthesize an important protein used to make skin, tendons, ligaments, and blood vessels. It is also necessary for wound healing, formation of scar tissue, and lastly, it is an essential nutrient for maintaining healthy cartilage, bones, and teeth. So it's always good to make sure you have a good amount of vitamin C. You don't want to be deficient or low in vitamin C, because deficiency in vitamin C can lead to multiple things that aren't good. It can lead to weak bones, weak teeth, fatigue, easy fatigueness, shortness of breath, your gums being weak, and whenever anything happens, they're really sensitive and they can bleed really easily. Scurvy is also a very characteristic of deficiency of vitamin C, and in very severe cases, lack of vitamin C can even result in death. So vitamin C is one of the several vitamins that are water soluble. Excess amounts of water soluble vitamins leave the human body through the urine and cannot be stored. While vitamin C is synthesized by plants and some animals, it is not synthesized by humans. That means that you can't just take one supply of vitamin C in your lifetime and be like, okay, I'm good. No, you would have to continuously, on a daily basis, get the vitamin C throughout your diet. It's also recommended daily allowance for vitamin C is a 60 milligram dosage for adults. Whether you get that from a supplement or a vitamin C tablet, or you just get that from your plain orange juice, it's always good to have some vitamin C in your body. It's also found in a lot of different fruits and vegetables. And so yeah, it's an antioxidant. Vitamin C, it's really good for you, and it's also very important to have in your body. So let's go ahead and let's look at the oxidation and reduction titration. So one type of titration is a reduction oxidation titration, and in this titration, electrons are transferred from the reducing agent to the oxidizing agent. And oxidation, which we learned in previous labs, refers to the loss of electrons. And although it says reduction, you're not losing, you are actually gaining electrons, which can be kind of confusing, but yeah. So let's go ahead. In this experiment, like I said before, a standard curve is prepared using solutions, and we're going to compare it to the unknown sample and see how it goes. So the materials included materials needed in this lab is the dichlorophenolindophenol, the DCPIP, which is right here. We have the vitamin C, also known as the ascorbic acid, graduated disposable pipette, the 5 ml syringe, 25 ml Erlenmeyer flask, 250 ml beaker. We have the 50 ml graduated cylinder. We also have the electronic balance with the batteries turned on. We have the weight boat, 2 of them actually, plastic spoon, plastic cups, 3 of them. We got the 2 different medicine cups, disposable pipettes right here. We got more right here. A wax or grease pencil, and we also got the water right here. So let's go ahead and jump into the experiment. I'm wearing my safety stuff. I got my gloves on, I got my goggles on, and I got my apron on, and the whole table is set up to where it was disinfected, and I have my electronics pushed away when I start the experiment. Okay, so as I said before, doing a titration, it's very important because you don't want to add too much of the different solution, because whether it's a 0.1 ml or half an ml, that could make a big difference in the whole experiment, and it could also change and alter your experiment results. So let's go ahead and let's start out. I've already done the pre-lab and all that. So we're gonna get the 250 ml beaker, and we're gonna fill it with pure water. We got that filled with water. And write the following labels in the 3. So we're gonna label the 3 different cups. We're gonna do waste. I'm gonna try W for waste. A for ascorbic acid. And unknown, right? U, question mark. This is the unknown. So we got all 3 of the cups labeled right here. And I'm gonna go ahead and get the experiment starting, and we'll see how it goes. Thank you.